Hi everyone and welcome to another video from Experiencing IT. Today I'm showing you how to turn a Raspberry Pi into an OpenVPN sharing gateway. Stay tuned. So, for the hardware you need a Raspberry Pi, of course. I'm using a Raspberry Pi 3 A+ for this project. I would advise you to use at least a Raspberry Pi 3. I started this project using an older Raspberry Pi 1 Model B and the results were not impressive. You'll need a microSD card. I'm using a 16GB one, but this is overkill. I believe you'd get away with a 2GB card as the full installation is only around 1.5GB. Because I'm using a Raspberry Pi 3 A+, which doesn't have an Ethernet port, I must use a USB network adapter. And you'll need, of course, a power adapter. That's it. Let's install Raspberry Pi OS. Okay, to install Raspberry Pi OS, you first need to download and install the Raspberry Pi Imager. Download and install it from raspberrypi.com/software. Once you have it installed, open it. Don't forget to insert the SD card in the computer and click on Choose OS. Let's click on Raspberry Pi Other and let's choose Raspberry Pi OS Lite. 64-bit if you are using a 64-bit Raspberry Pi and 32-bit if you are using a 32-bit Raspberry Pi. I believe all Pis before Raspberry Pi 3 are 32-bit. Now, click on Choose Storage and make sure you select the correct storage if you have more than one storage device plugged in. In my case, I only have one, so I'm going to go ahead and select the SD card. Now, click on the gear button to set some extra settings. Let's enable SSH and let's set the username and password. If you'd like to set your original settings, you could do so by scrolling down and set the local settings. I'll leave mine as they are and I am going to click on Save. Finally, to write to the card, click on Write. Just click Yes on the next message. And now it's just a matter of waiting for the image to be written onto the SD card. Once finished, click on Continue. And now it's time to boot up the Raspberry Pi with Raspberry Pi OS. Insert the card in the Raspberry Pi, plug in the Ethernet cable, and finally, plug in the power adapter. Pay attention to the green light on the Raspberry Pi. Once you see that light stop flashing, the boot process should have ended. This took around 2 minutes to complete, and as soon as it ends, we're going to connect to the Raspberry Pi using SSH. Just before connecting, we need to find out the Raspberry Pi's IP address. The Raspberry Pi is configured to get an automatic IP address on boot, and to find out that IP address, you could log into your router and find out which IP address has been assigned to the Pi. Maybe this is the easiest way, but because all routers are different in showing which clients are connected to the network, I'm going to use a network scanner. If you'd like to use the same network scanner, download and install Advanced IP Scanner from the address shown on screen, and once installed, open it. Now click on Scan, and on the Below pane you will see all the IP addresses on your network. You just need to find the one you don't recognize. Okay, now that the scan has finished, The IP address that I don't recognize in my network is the one that is not masked. All the others are familiar to me and I know what they are in my network. So this is the IP address I'm going to use to connect via SSH. Okay, to connect to the Raspberry Pi, I'm assuming you are using Windows, but the procedure should be similar on other OSs. To connect via SSH, right-click on the Start menu and choose Run. In the Run box, type cmd and press Enter. And now on the command line window, let's type in SSH and now the username configured in the Raspberry Pi imager. If you remember, I left mine as pi, so I type pi@ and now the IP address of the Raspberry Pi, which in my case is 192.168.3.236, and I'm going to press Enter. If you get this message, which you should, type in yes and then Enter. Now I type in the password that was also configured in the Raspberry Pi image, and we are in. It's time now to update the Raspberry Pi. Okay, to update the Raspberry Pi, we type in sudo apt-get update and press Enter. Let's wait for all sources to be updated. And now we type in sudo apt-get upgrade. You'll get a prompt informing you how much disk space will be used after the operation. You should press Y and Enter to continue. Okay, and now with the Raspberry Pi updated, it is now time to configure a static IP address. Okay, because we are using the Raspberry Pi as a gateway and we don't want it to be changing IP addresses randomly, we need to configure a static IP address. Which IP address? Well, first you must look at your router's DHCP pool. As you can see from this image, my DHCP pool goes from 200 to 249. So all IP addresses under 200 are available for me to use. Knowing this and knowing that my main router is configured as 192.168.3.1, I'm going to configure the Pi's IP address as 192.168.3.2. If you'd like to check your router's IP address, type in IP space R and press Enter. Now, to set the static IP address, type in sudo nano/etc/dhcpcd.conf and press Enter. Now scroll down in the file and find the block that reads example static IP configuration. I'm going to remove the comment from the line eth0. Also, I'm going to remove the comment from the line static_IP address, and I am going to set the IP address to 192.168.3.2. Uncomment the static router line and type in the IP address of the router. I will also uncomment the static domain name server line and configure it with the IP address of the router. Now, to save the file, press Ctrl+O. Ctrl+O. Press Enter to confirm and Ctrl+X to exit. So now let's reboot the machine. While the machine reboots, let's do a ping and wait for the machine to come back up. Now that the machine is again online, connect to it via SSH, pointing to the new IP address. Because the IP address changed, we need to add it again to the list of known hosts. So type yes and then press enter. If we now type ifconfig, we can see that the IP address has been correctly changed. Okay, to install the OpenVPN binaries, type in sudo apt-get install openvpn-y and press enter. Let's give it some time to finish installing. Once done, I'm going to navigate to the OpenVPN client folder by typing cd/etc/openvpn/client. In this folder, I'm going to create a new folder called conf-files. This is where I'm going to store the OpenVPN config files. Okay, now we need to download the configuration files for the VPN provider. I'm using Pi VPN. You'd have to search for the configuration files for your OpenVPN provider. So in the browser, I'll just search for Pi VPN config files. And if I scroll a bit down, there's a link with that exact question. Opening it and scrolling a bit down, I see the links for the configuration files. I'm going to copy the link. And then, back at the console window, I'm going to change directory into the config files folder. And I'm going to type sudo wget, and I'm going to paste the link I just copied, and I'm going to press enter. So it was a quick download. The files come in a zip file, so it's needed to unzip them. For that, I'm going to type sudo unzip openvpn.zip. Now, with the files unzipped and going back to the main client directory, I'm going to create the authentication file where I'll store the username and password to connect to the VPN service. For that, I'll type sudo nano auth.txt. Remember that these file names can be whatever name you'd like. Just remember to change them in the examples. On the first line, I'm going to type in my username to connect to the VPN service. And now, on the second line, I'm going to type in my password. To save, I'm going to press Ctrl-O. And I'm going to hit Enter to confirm. And to exit, I'll press Ctrl-X. Now, let's secure that authentication file to prevent anyone from reading it but us. Type in sudo chmod 600 auth.txt. Okay, and with this done, it is now time to test the VPN. For that, I'm going to type the instruction seen on screen. The configuration file that I've chosen is a configuration file that I'm used to work with, which is France, but I could have chosen any other file. Once the instruction is all typed in, I'm going to press enter. And this means success. Now, if I type ifconfig, you'll see that we have the tunnel established. That's awesome. Let's set up now the VPN to start automatically on boot. Okay, now to set the VPN to start on boot, type in the following: sudo nano etc/rc.local. Scroll down to the end of the file and just before the line exit 0, type in the instruction to launch the VPN connection. Press Ctrl O to save, and then Ctrl X to exit. And now let's reboot the machine. Once the machine rebooted, let's type in ifconfig and the tunnel should be up. If all went as expected, it is now time to configure forwarding and install and configure the firewall. Okay, to enable IP forwarding, type in sudo nano/etc/sisctl.conf and press enter. Scroll down and then comment the line net.ipv4.ip_forward equals 1. Now again, Ctrl O and enter to save, Ctrl X to exit. I'm going to leave links in the video description for you to read all about what we are doing here. So now let's move on to install and configure the firewall. To install iptables, the firewall, type in sudo apt-get install iptables space iptables-persistent-y and press enter. Let's give it some time to finish. Let's say yes on both IPv4 and IPv6 messages to save the existing rules. Okay, now that the firewall is installed, let's configure it. As mentioned previously, I'll leave links in the description for you to read and understand what is being done here, if you'd like to do so. Now type the instructions that you are seeing on screen. Pause the video if necessary. Okay, once done, and to save these rules and to have them restored on boot, type netfilter-persistent save and press enter. And now let's reboot the machine. With this configuration, we have now the traffic being routed to the internet through the tunnel. So let's set up this machine to use the Raspberry Pi as the gateway and check if this is really working. Right, on my Windows machine, I'm going to assign a fixed IP address just to test if the VPN gateway is working correctly. And later, I'll tell you how to configure so that all machines on the network share the gateway. Now, on the command prompt, I'm going to type ipconfig to check the IP address that has been assigned to this computer. I'm making a mental note of it. And now, on the control panel, I'm going to network connections. Okay, just before continuing, To get here, you must go to Settings, Network, and Internet, and go to Change Adapter Options. Now, I'm going to right-click on my Wi-Fi connection, select IPv4 and click on Properties. I'm going to select Use the following IP address, and I am going to configure the IP address that was assigned to this machine via DHCP. As mentioned, this is a temporary configuration to test the VPN gateway. The default gateway address, I'm going to insert the Raspberry Pi's IP address, which, if you remember, is 192.168.3.2. And for now, the DNS IP address, I'll keep the IP address of the main router, which is 192.168.3.1. And I'm going to click OK. Now, going to a web browser, I'm opening this website, dnsleaktest.com, which will tell you where in the world you are connecting from. I'm going to force a refresh here, and as you can see, we are connecting from France, which is the VPN server to which I'm connected in the Raspberry Pi. So now let's speak about DNS leak. So, first, what is a DNS leak? According to Wikipedia, a DNS leak refers to a security flaw that allows DNS requests to be revealed to ISP DNS servers despite the use of a VPN service to attempt to conceal them. What does this mean? This means that even though you are connected to a VPN service, your ISP can see which websites you may be visiting. To prevent that, we should use either the VPN service's DNS servers or third-party DNS servers, such as Google or Cloudflare. So, if I run now a DNS leak test on this webpage, you'll see that it tells me that I'm in Spain, despite being connected to the VPN, which is connected to France. To bypass this security flaw, I also configured the Raspberry Pi to act as the DNS server. I tried to configure my VPN provider DNS addresses on the main router, but the results were not that good, taking a long time to resolve the names and sometimes even failing DNS resolution. Having the Raspberry Pi act as the DNS server, I had no issues. So that is the approach I'm showing you here. You might want to do your own testing and see which approach serves you best. So next up, I'm going to install a DNS server on the Raspberry Pi. Okay, to install bind9, the DNS server, on a new SSH session, type sudo apt-get install bind9-y and press enter. Once installed, let's edit the DNS server config file. Type sudo nano /etc/bind/name.conf.options. So, let's forget what you're seeing on screen right now. You don't need the line DNSSEC-enable because I later found out DNSSEC is enabled by default. And you also see that DNSSEC validation is set to no. Because I had some issues when starting the DNS server, but since then, with the Google servers, I had no more issues starting the DNS server. So my configuration file looks like this now. As you can see, I've decided to use the Google DNS servers as my forwarders. This helps with DNS leak, but not a lot with full privacy, and I'll explain that in a while. But to show you how setting up the VPN provider's DNS servers prevents DNS leaking and gives you full privacy, I'm going to show you the tests I made while recording. After making changes to the DNS configuration file, you should restart the DNS server. To restart, type sudo systemctl restart bind 9. And to check its status, type sudo systemctl status bind 9. Now I'll change my machine to use the Raspberry Pi as the DNS server. And if I now run a DNS leak test, you see that the test shows that I'm in France. Now, I'm going to show you a test using the Google DNS servers. As you can see, it no longer shows that I'm in France, but also does not show that I'm in Spain. The big difference between using the VPN provider's DNS servers and Google's DNS servers is that supposedly the VPN provider DNS servers should not hold any historical records of your navigation, giving you full privacy, while the Google servers are, for sure, recording all your activity. So this is how DNS leak is prevented. Let's see now how to share the VPN with all the LAN. To share the VPN gateway with all the clients on the network, you must configure the main router's DHCP server to use the Raspberry Pi as the gateway and DNS server. If you'd like isolated clients to navigate the internet using the gateway, you must do as we've been doing so far, which is change the IP settings manually, making sure that the configured IP address does not match an IP address reserved for the DHCP server, or it could lead to an IP address conflict. Okay, let's run some speed tests and end this video, which is already quite long. So, I'm doing a couple of speed tests here. The first one, I'm not connected to the VPN gateway. And on the second one, I'm connected to the VPN gateway. The speeds achieved using the VPN gateway are not impressive, but they are nonetheless quite usable. If you'd like, for example, to connect to another country's streaming services. They are even quite usable for navigating the internet. One other thing to take in account is that maybe my VPN provider is slow by itself, and it is capping the speed that I can achieve while connected to the VPN. You'd have to do your own testing with your VPN service provider. Anyway, I hope you enjoyed the video. If so, please like and subscribe, and I see you again soon.